Hi, so in this video we're going to learn about something called the unit circle, and the unit circle is really useful in trigonometry. So let's get started. So all the unit circle is it's a circle where the radius is 1 and it's on the xy plane, and the center of the circle is at the origin, so 0, 0. And the radius of the circle is 1, so I've written r equals 1 right here. And the interesting thing happens is when we take a point on this unit circle, so the equation of the unit circle is x squared. I'm going to talk about this first. So let's say we have a point on the unit circle with radius 1 called x comma y. So that means this part of this, see how this thing makes a triangle? So this part of the triangle has length x, and this part of the triangle has length y. Right? Because the y coordinate here is y, so that means this height here is y. The x coordinate here is x, so that means this height here is x. This length here is x. So right here, we have a right triangle. And remember, the hypotenuse has length 1. Because remember, the hypotenuse is just the radius. So it's 1. So now, let's say we have an angle theta here. Now, what would y be equal to? So, what is the sine of theta? Well, the sine of theta, this theta right here, the sine of that equals y divided by the hypotenuse, since y is opposite to the angle, and then the hypotenuse is just 1. So we get sine of theta is equal to y. So this is interesting. Now what about the cosine of theta? Well, cosine is adjacent over hypotenuse. In this case, the adjacent side to the angle is x. So we can say that cosine of theta equals x over 1, which is just x. So sine of theta equals y, and cosine of theta is equal to x. So we can replace these coordinates with cosine of theta, comma, sine of theta. So that means if we have any angle theta in this circle, then the x-coordinate of the point of intersection of the radius with the circle is cosine of theta, and the y-coordinate is sine of theta. Okay? So this is the unit circle. The x-coordinate is cosine of theta, and the y-coordinate is sine of theta. So now what I'm going to do is I'm going to erase this triangle right now, and then we're going to do an example. So let's say we have an angle on this circle of pi over 3 radians. Now remember, we can convert from radians to degrees, which is what I showed you in the last video. So if we use the formulas from the last video, we get that pi over 3 radians equals 60 degrees. Okay? So this angle here is 60 degrees. And here's the point where the radius meets the circle. So the radius at that angle meets the circle. And remember, the coordinates are cosine of theta, comma, sine of theta. So theta is 60. So what would the coordinates of this point be? Well, cosine of 60, which is, the cosine of 60 is 1/2, and the y-coordinate would be the sine of theta, which is sine of 60, which is square root of 3 over 2. So the coordinates of that point are 1/2 comma square root of 3 over 2. Let's do another example. Let's say that theta is pi over 6 radians, or 30 degrees. So the coordinates of this point would be cosine of 30 degrees, which is square root of 3 over 2, and then sine of 30 degrees, which is 1/2. This is kind of the opposite of what we got here, the 60-degree angle. Now, what happens if we have a 90-degree angle, or pi over 2 radians? So if we have an angle of pi over 2, or 90 degrees, what would the x-coordinate over here be? Well, it's on the y-axis, so the x-coordinate would be 0. And what's the y-coordinate? Well, the circle has radius 1, so the y-coordinate would be 1. So this coordinate here is 0, 1. But what did we learn? We learned that the coordinate is cosine of theta, sine of theta. So we can say that the cosine of pi over 2, or 90 degrees, is 0, and the sine of pi over 2, or 90 degrees, is 1. So we can actually use the unit circle to actually find the cosine and sine of an angle. Pretty neat, right? So that's what the unit circle is for. And in the next few videos, we're going to go over the coordinates of some of the angles on the unit circle. And until then, I hope you like this video.